Alright everyone, welcome back to this channel. In this tutorial we'll talk about variable separable differential equation of the first order. How to obtain the general solution of a first order separable differential equation. Now, what is a separable variable differential equation? A differential equation that can be written in this form: dy dx equal to h of x times, let's say, g of y. Or if I can write the differential equation as dy dx equal to h of x upon g of y. So a differential equation of this form, any of this form, is a separable differential equation. The idea is that the function involving x can be taken to one side with dx, and the function involving y can be taken to the other side with dy. Let us see. From this first equation now, we can cross multiply to obtain dy equal to h of x times g of y times dx. Alright, that is, if you cross multiply now, over 1. This times this, we obtain this. This times this is this. So if I divide both sides by g of y, I'll have 1 upon g of y dy equal to h of x dx. What can you see? This is 1 over g of y dy. That is, the term involving y is on one side with dy, and the term involving x, h of x, on the other side with what? Dx. So the equation is separable variable. That is, the variables can be separated. That is it. So any equation that can be written in this form, a differential equation, or this, they are called separable variable differential equation, or variable separable. In this case now, we can cross multiply to obtain g of y dy equal to h of x dx. Yes, it is still separable variable. So we are going to obtain the general solution to some differential equation by separating the variables. Okay? Remember to subscribe to this channel if this is your first time of joining us. Turn on notifications as well so you get updated whenever videos come up in the future. Now, this is the first question I have here. We have to solve the differential equation dy dx equal to 2x upon y plus 1. Let's solve this. It is easy. We can actually separate the variables, the function of x and dx on one side, and the function of y and dy on the other side. If we cross multiply now to clear the fractions, dy times this, that's y plus 1 dy, equal to 2x times this, that's 2x dx. It's easy. So the function of y and dy on one side already, the function of x and dx on the other side. So what we have to do now is to integrate both sides. So we'll take the integral of y plus 1 dy equal to the integral of what? 2x dx. Integrate y dy, we have y squared upon 2. By the rule of integration, the power of y here is 1, add 1 to it, it becomes 2, then divide by the 2. So we have y squared over 2. Then if we integrate 1 dy, we obtain, that's 1y to the power of 0 plus 1 all over 0 plus 1. I'm just going through the steps. Okay, so this is it now. The integral of 2x dx is 2s, the power of x is 1. So 1 plus 1 all over 1 plus 1 plus c. Okay, so we have this y squared upon 2 plus, this is actually y. Everything here will reduce to y. 0 plus 1 is 1. Y to the power of 1 is y. This is 1. So y over 1 is y. 1 plus 1 is 2. So 2 will cancel 2. And we have x squared left. This is 1 plus 1, 2. X squared plus c. So we can choose to clear the fraction by multiplying all through by 2. And if we do that, we'll have this. Y squared plus 2y equal to 2x squared plus 2c. So this is the general solution to this differential equation. All right, let us see some other examples. Question 2. We have to find the general solution to this equation. Dy dt is equal to t squared into 1 plus y squared. All right, here the dependent variable is y and the independent variable is t. So let us separate the variables. The variables are separable, that is, they can be separated. Okay, let's cross multiply. If we cross multiply, dy will be equal to t squared into 1 plus y squared dt. All right, this is over 1. So this time this is this time this is this. At the right hand side, we have the function of t, the function of y, and dt. Okay, so let us just remove this function of y. That's this term involving y, and take it to the other side. And we can do that by dividing both sides by 1 plus y squared. 1 plus y squared. So 1 over 1 plus y squared dy is equal to, this we cancel this, t squared dt. So having done this, we can now take the integral of both sides. The integral of 1 over 1 plus y squared dy is actually the tan inverse of y. Yes, there is a standard integral that says that the integral of 1 over x, 1 plus x squared dx is equal to the tan inverse of x plus c. So it is a standard integral actually. So the integral of 1 over 1 plus y squared is arc tan y, or tan inverse of y. And the integral of t squared dt is t to the third all over 3 plus the arbitrary constant c. That is, add 1 to the power and divide by 2 plus 1. And so this is what we have. From here now, we can just take the tan of both sides to eliminate this tan inverse. So we can say tan inverse of y is equal to the tan of what? T cubed all over 3 plus c. So that tan will take away tan inverse. Y is now equal to tan t cubed all over 3 plus c. So this gives the general solution to this differential equation, the equation that we are given. All right, look at the last question under this separable variable equation. Now to solve the differential equation, dy dx equal to y squared minus 4 all over x. Okay, this is separable variable, so we can actually solve it. If we cross multiply, we'll be having dy as x times x dy equal to this times dx, that's y squared minus 4 dx. Now, at the left hand side, I'm having x dy. At the right hand side, I'm having y squared minus 4 all into dx. This is not what we want, all right? We want the term in x and dx on one side, the term in y and dy on the other side. Let's divide both sides by x and by y squared minus 4. I want to do it simultaneously. If I divide both sides by x first, x will leave here and come here at the denominator. And if I divide both sides by y squared minus 4, it will leave here and come here at the denominator. So I'm having this 1 all over y squared minus 4 dy equal to 1 over x dx. At this point now, we can integrate both sides because we have separated the variables purely. So integrating both sides, we have this. Actually, I can integrate 1 over x dx to obtain ln x plus c. The derivative of x, that is, the derivative of x with respect to x is 1. And I can see 1 at the numerator. So if I integrate 1 over x, the integral is ln x plus c. Ln, take note, is the logarithm to base e. We call it natural logarithm. Good. So let us now integrate 1 over y squared minus 4 with respect to y. That is the next thing. To integrate this, I will have to break it down into partial fraction. Yes, 1 over y squared minus 4 will be broken down into partial fractions. So let us decompose it and see. 1 all over y squared minus 4. What will it be? Y squared minus 4 is the same thing as saying y squared minus 2 squared. Yes, because 2 squared is equal to 4. And this is this. By difference of 2 squares, y squared minus 2 squared is y minus 2, y plus 2. So everything here, they are equivalent. So it is this we are going to break down into partial fractions now. You can watch my video on partial fractions. Okay, I have videos on them already, so you can watch so that you understand how to resolve a compound fraction into its component partial fractions. Here I have at the denominator 2 linear factors, y minus 2, y plus 2. Since we are having linear factors for each, I will assign constant and add them. So I have 1 all over y minus 2, y plus 2 equal to, the LCM of this is y minus 2, y plus 2. The same thing as what we have here. So this divided by y minus 2, we have y plus 2 times a. That's a into y plus 2. This again divided by y plus 2. That's y minus 2 times b. That's b into y minus 2. They can cancel out. And so we have 1 equal to a times y plus 2 plus b into y minus 2. Now, let me use the cover-up method to determine a and b. What value of y, for example, I want to eliminate a. What value of y will I plug into this equation to make everything here equal to 0? If I put y equal to minus 2, minus 2 plus 2 is 0. Everything here becomes 0. So when y is equal to minus 2, we have 1 is equal to, everything here is 0. Minus 2 is minus 4 times b, minus 4b. So if I divide both sides by minus 4, it means that b is equal to minus 1 over 4. That's what it means. Okay, let us get a. We chose the value of y to make this entire expression disappear. Okay, so what value of y are we going to choose now to make everything here 0? When y is equal to 2, if I put 2 here, 2 minus 2 is 0. So everything here becomes 0. We are now having 1 equal to 2 plus 3 is 4. 4 times a, 4a. So from this now, a is equal to 1 all over 4. So what will be the partial fraction resolution of this compound fraction? Remember, this and this, they are equivalent. They are the same. So this is it now. A, what's A? 1 over 4. Okay, let me put it here. 1 over 4. And what's B? Minus 1 over 4. So the minus will affect the plus, and we have minus 1 all over 4. Which you can write as 1 all over 4 into y minus 2 minus 1 all over 4 into y plus 2. Y plus 2. So if I decide to bring 1 over 4 out, for example, because 1 over 4 is common to both, I will have something like this. The integral of 1 over 4 into 1 over y minus 2, then minus 1 over y plus 2 dy. Right, okay. This one gave us ln x. Let me put it down. Equal to what? Ln x plus c. But I hope you understand this. So 1 over 4 is a constant. It can be brought out. We have 1 over 4 times the integral of 1 over y minus 2. Okay, let me just do it this way. Times dy and minus the integral of 1 over y plus 2 dy also. All equal to ln x plus c. So we can integrate now. Alright, let's go ahead. We have 1 over 4 into the integral of 1 over y minus 2 dy is ln y minus 2. Ln y minus 2. It's simple. Just the same way we got ln x here. We said that the derivative of x here is 1. That is, derivative of x with respect to x is 1. So the integral of 1 over x is ln x plus c. So in this case now, the derivative of y minus 2 with respect to y is 1. How is it? Differentiate y with respect to y, we get 1. Minus 2 is a constant, so the derivative is 0. So we got 1. Okay? So that is how the integral of 1 over y minus 2 dy is ln y minus 2. Then minus the integral of 1 over y plus 2 dy is ln y plus 2. Differentiate y plus 2 with respect to y is 1. So we have ln x plus c. So what we have to do now is, let me multiply both sides by 4 to eliminate this fraction. So we'll be having at the right hand side 4 into ln x plus c. That's 4 ln x plus 4c. Multiply 4 by this. So at the left hand side, this is what we'll be having. Ln y minus 2 minus ln y plus 2. So by the law of logarithm, we have log a log b to base a minus log c to base a. They have the same base. Logarithm says take the log to the same base of that a and divide b minus all over c. So this will now be ln y minus 2 all over what? Y plus 2. Now I want to take away the ln. To remove the ln, I will exponentiate both sides. This is it. Exponentiate both sides. That is e to the power of ln y minus 2 all over y plus 2 is equal to e to the power of 4 ln x plus 4c. So another law of logarithm we are going to apply here. We are just applying law of logarithm as if we are solving logarithm problem. It's okay. Now this is e to the power of ln y minus 2 over y plus 2. The law of logarithm says that if we have a raised to power log b to base a, the a here will cancel the log and the base a, leaving us with b. So remember that natural logarithm is log to base e. So this e we cancel the ln, alright? We are having y minus 2 all over what? Y plus 2 left. I want to simplify this now. By the law of indices, I can write this as, okay, just watch. By the law of indices now, we have e to the power of 4 ln x times e to the power of 4c. Yes, because they have the same base, so I can actually add their powers. This is equivalent to this. So the law of logarithm also says that if I have something like this, ln, or let me use a log b to base a, where b has the power of c, it is equal to c, the c will stay at the back, all right? We have c log b to base a. So it is reversible, it can go forth and back. So in this case now, we are having 4 ln x. The 4 can stand as a power of x here. And if that happens, we'll have e to the power of ln x to the 4th times e to the power of what? 4c. I hope you get this. Ln x to the power of 4 is equivalent to 4 ln x. Okay, so based on what we did here, this e will take away the ln. We are now left with what? Y minus 2 all over y plus 2 equal to x raised to the power 4 times e to the power of 4c. That's x to the 4th e to the power of 4c. Good. The equation is free from natural logarithms and logarithms in total. So in just one more step, we can clear the fraction. Okay. If we multiply both sides by y plus 2, we have y minus 2 equal to y plus 2 in brackets x to the 4th e to the power of 4c. So this is actually the general solution to the differential equation that we're given. It's no longer here, but there's a solution to the differential equation. We applied the method of separation of variables. Alright, I hope you enjoyed the video. Keep supporting by subscribing, like, and share this video to your friends and to your classmates. In the next video, I will solve a problem on this same separable variable differential equation, but that one will not be an initial value problem. Yes, we will apply initial conditions. Just stay tuned and keep following. Turn on notifications so you get updated whenever the video comes up on this channel. I'll see you there.